Hey everyone, this is the 6th video in a series of videos explaining Boolean logic gates with binary notation. If you haven't gone back and seen the first 6 videos, I suggest you do, considering this is the overview video, where we'll just be combining gates and going over Boolean algebra and its different forms one last time. Alright, so now we get to actually do the complicated things. I'm not going to use anything from Wikipedia this time because we're going to create our own logic gate that'll tell us something useful. So let's say your teacher tells you to pick up only 1 or only 2 pencils. Well, you could create a logic gate that detects if out of 3 pencils, I should say, out of 3. So we should create a logic gate that detects whether or not the student is following the teacher's orders. So if a student picks up no pencils, he is not doing the right thing. If he picks up any of the 1, he is doing the right thing. Or if he picks up any 2 pencils, he's doing the right thing. But if he picks up 3, he's not doing the right thing. So I have over here a truth table of the desired logic gate. We have our 3 inputs A, B, and C, and our output is D. So you can see that at first glance the teacher's orders would make us want to do something that detects if he has 1 or detects if he has 2, and they'd be connected by an OR gate. But it seems much simpler to me that all of these 1s would take a lot more gates to detect compared to these 2 zeros. So if all of these are 1s, you get 0, and if all of them are 0s, you get 0. So let's create a gate that's true for all 0s, or for all 1s, and then not it. So instead of getting 1s, make it false when these are happening. Alright, let's see if I can do this. So, if we had 3 inputs of 1, 1, and 1, and we wanted to make sure that every single input came out, if every single input was true, our output would be true, and only if that was it, we'd have to use AND gates. So A and B and C. I think this time I'll use the multiplication dots in the center because this is going to get really complicated really fast. Okay, A and B and C. Which means that if A is 1 and B is 1 and C is 1, we will get 1. But we want a 0 when all 3 of them are 1. So let's put a not overline over top. There we go. So if any of these become 0, the bottom gate becomes 0, and a not over top means it's a 1. Kind of like a large NAND gate for 3 inputs. Now, how about the other one where, if you remember, if we had 3 zeros, we wanted to produce a 0. So, we have nothing that only works on zeros. Let's think. Well, if you recall, back before when we were doing the OR gate, the OR gate given 2 inputs is true all the time unless it has both false. So if we were to put in, let's say, A or B or C in brackets, this is supposed to come out true if we have all zeros. So if we put 0 or 0 or 0, we're going to get 0. So what we need to do is put a not over the entire thing. Alright, so now if we put in 0 or 0 or 0, we're going to get 1, because it's knotted at the end. And if we put in 1 and 1 and 1, we're going to get 0. Oh, I don't think I need that overline. Let's just turn those into brackets. Because if we have 0 or 0 or 0, we're going to get 0. And if we have 1 or 1 and 1 and 1, we'll still get 1. That way, 1 or 0 or... So, yes, with all three ones, we'd get 1 or 0, which is 1. And if all three zeros, we'd get 1 or 0, which is 1. And then if we put a not over this entire thing, there. That should be our gate. Now, be careful, because this overline over the three inputs isn't actually a NOR gate. A NOR B, if there wasn't a C, if I were to cover the C up, it would be a NOR gate. But because there's three different inputs, this is entirely different. So let's try making this in the logic lab. We have our three inputs, which represent our three pencils. Let's spread them out a little bit more. And we're going to need to separate these. Connect them to their separators. Now first, add A and B and C. Sounds easy enough. A and B. So we have A, B, C, and C. There. And then we can also do or get it to connect to afterwards. And then at the other side we had A or B or C underneath the knot. So, or put this one here. C or B. So back so it looks symmetrical for fun and profit. There we go. And then a knot in front of that. Connect those to the OR gate. And move that back so I can make space for this NOT gate. Actually, let's move this forward. You don't want to get too messy here. NOT. And now I need to grab a light. There we go. Output. So picking up no pencils gives you false. Picking up any one of the pencils gives you true. Picking up any two pencils also gives you true. Picking up three pencils gives you false. So this is the gate that would describe what the teacher wanted earlier. Check. Done that part. Alright, and the last part of this video I'm going to overview the different forms of binary notation. And with the magic of television, I have a table I made earlier. So, on the top are the different styles of and. You'll see here's the one we've been using. I sometimes drop the dot in the center, but that's the style I have been using. For or, I've been using the plus sign. For not, I've been using the overline. For nor, I've been using the overline and plus sign. And for NAND, I've been using the overline and dot. But what you'll see is these are often seen on websites because they're more mathematical and mathematicians use them more often. I don't quite like them because it's something new to learn, but if it jives with you, go right ahead. Also, on this side are the symbols for union and intersection, which is what these are for in mathematics on functions. So either of these can be used, but I like to use these ones. For not, this is like the actual not symbol. The overline isn't as common, although I do like to use it. This one's kind of used with these two over here. What I should mention is that you'll never see these two forms mixed. You won't see an up triangle for and the plus sign for or in the same formula. That's just really bad form. So up arrow and down arrow for and or, dot or plus and plus sign, and U or upside down U. The overline could be used with, I think, pretty much about any of them. This symbol, I think I've only seen used... actually, yeah, I've seen this symbol used with all of them as well. The nor, this is the same as this one, except they're using the more standard not symbol. These down arrow, up arrow notation, it's what I've been seeing on some websites, including Wikipedia, and I don't think they're all that popular, but it's good to know them in case. So, here's just binary notation. Glad that you're able to watch all these videos with me, and please leave some comments so I know what to improve on if I ever do this again, and thank you.